talk. It's great to see so many regulars. We have people who pop in every day for these talks. Thank you very much. And welcome to the new people. Our speaker today is Andrew Johnstone. He's the founder and the CEO of G.I.S Group of Companies. He has over 35 years experience in the water and environmental consulting for mining, industrial, waste, oil and agriculture in Africa. He's undertaken and managed water and environmental investigations in 16 countries through Africa and also in the Czech Republic. Andrew has authored 17 papers around groundwater supplies, geochemistry and the hydrological impacts of mining. He's been project lead on a South African Water Research Commission funded He's been the project lead on a South African Water Research Commission funded study to determine if pit lakes are an environmentally sustainable closure option for coal mines in South Africa. He's been part of the South African Water Research Commission project technical advisor team and a member of the technical review committee for the IMWA journal, Mine, Water and Environment. Today, Andrew is going to be talking to us about the collection of baseline environmental and social information during the geological exploration phase. Thanks, Andrew.
Thank you. Good afternoon, all. Thanks, Darlene, for the introduction. I'm going to go through what I think is an incredibly interesting aspect, and it's really aimed at the exploration fraternity in terms of collection of baseline environmental and social information during the geological exploration phase. I think that geologists are ideally set to collect this information during the exploration phase, and as a result, I think that that just some idea of what information is required for environmental permitting and social permitting of these mines, it gives some insight into what information should be collected. I'm going to mute my video and then I'm just going to go with the PowerPoint presentation. And I'm very happy to answer questions after the session. Thank you. So just to go through, this is the collection of baseline environmental and social information during geological exploration. Okay, so the aim and introduction is just the collection of early baseline environmental information is critical for the long-term project. This is ideally managed by the exploration geologist, and why the exploration geologist is he's usually the first person on the sites. He is involved with the first set of intrusive work that's on the site, and as a result, he is the ideal person to be able to start collecting this information and also to then record the information during the whole exploration phase. We often find that in these projects that no baseline information is collected during the exploration phase, and as a result, when the project goes from from pre-feasibility to feasibility to bankable, we don't have that information. And some of the information is obviously critical because there's seasonal variations. For example, in wetlands, during the winter periods, when you if you had to start a baseline environmental information during the winter periods, you're not going to get all the information that you require from a wetland because most of those plants are only active during the summer periods. So just to go through, so I'm going to go through the collection of legal information, social information, that is community, land use and infrastructure. I'm going to go through some of the environmental information that you can collect, and then the ongoing monitoring and recording of this information. So you've obviously seen all these news headlines, and I think environment and social issues are becoming a major consideration during a project's pre-feasibility, feasibility, or bankable feasibility study. And here's just some headlines that I actually managed to get from some latest publications. I mean, for instance, Paladin wants to sell its Kayalakela project, and they're getting bombarded with a whole lot of information regarding what is the state of the project, what's the contamination, what's the future contamination, and it's a uranium project. Parenti is exiting northern Burkina Faso because of a risk in terms of social risk from that area. You can look then at some other places like Cordell Sieves environmental and social assessment for approval of a Mali project. And as soon as these approvals have actually have been given, and obviously you've got to have the right information to get the approvals given, the project really goes into the next phases. Plus also, it actually adds a lot of value to the project because now you receive information to actually go or approval to go ahead with the project. So in terms of the importance of collection of baseline information during exploration, it obviously streamlines the environmental authorization process. It informs the social impact assessment and it identifies the required legal requirements and also the stakeholder agreements that you need to put into place. We always say in terms of these stakeholder agreements, one of the interesting things is that, you know, the community or the landowner's interest in the project is not that great when the exploration holes are a kilometre apart. When the exploration holes are 500 metre apart, obviously they become more and more interested, and obviously their expectations in terms of the price of land goes up exponentially. So by the time you're getting to 50 or 100 metre grids, the expectation from the communities is obviously a lot higher than it was when you started the exploration phase. So it's critical that you get these stakeholder agreements in place. So in terms of the baseline information you want to record is ecology, soil, water, fauna and flora, and seasonal variations. It enables you to establish an early and lengthy database. And as I said earlier, exploration geologists are ideally positioned to collect this information or arrange for this information to be collected. So just some discussion points I want to go through. I want to look at it where environmental and social baseline studies come in the mining life cycle, what entails an environmental and baseline social study, environmental and social baseline study, and where do they fit in these studies, what are the benefits of environmental and social baseline studies, and how do we make it happen. So in terms of the mining life cycle, what happens is that you usually have your geoscience surveys on the potential resource, and that is done at a desktop stage. Then you go into exploration, and obviously this is to prove the resource. Then you start looking at the engineering design and of the mine infrastructure and layout. Then you get the mine development, then you get the extraction process, and obviously the closure process at the end of the day. So where do these environmental, social, and baseline studies fit in? They usually fit in the exploration phase, because then you actually got access to the land and you're able then to actually collect this information. However, you can do some desktop studies, and I'll elaborate on that just now. So in terms of looking at this, in terms of prospecting, exploration, design, development, production, and closure, the environmental baseline studies come between prospecting and exploration. In that area there are the environmental social impact assessments are usually started between the exploration phase and the design phase. And then the authorization obviously has to occur prior to development of the mining process. So we have to collect all this information, enable for the proponent to table an environmental social impact assessment that actually then covers all the aspects of environmental impacts, social impacts, and the mitigation measures that the proponent is going to put in. So in terms of getting this document into World Bank or country-wide requirements, it's critical that you have this information to make the project or make the document stand to scrutiny. So the other critical thing is the establishment of an environmental and social based database, and this is critical to develop a database and to collect this information. This information must be geographical, it must be coordinate driven, and it must be the collection of time series data, typically water levels or water quality, and it must be available to all stakeholders. So as a result, you're then able to have a cloud-based database which is available to stakeholders, which might be the mine designers, might be the proponents, might be the exploration geologists, so people can assess this information and see how the information is built going forward. You can actually bring your specialists in here as well, where they can have some input into water quality or monitoring. eSimon is a typical environmental database that is used for this application. So in terms of the desktop review, and this could come from during the exploration phase where the desktop work has been done, where you're looking at geological mapping, airborne geophysics, or something like that. The one is to look at the legal review of the legislation, and you then have to determine what legislative requirements you're going to require going forward, either for the exploration permits or for the potential mining permits. You can also look at desktop assessment of ecology, land use, social context, and the water issues that are associated with the proposed project. You can then look at historical data in terms of there is data on groundwater, surface water quality, ecology, or community data. And here you're able to identify project risks, and you're then able to build the database to actually look at these project risks. If in your exploration area you have protected areas, you know that these protected areas are going to be sensitive, and there's going to be, the big if you get permission to mine in these protected areas, you're going to have a lot of information to support your applications. You also have to look at important water resources, what the potential impact of the exploration and also the mine developments will have on these water resources, or where the water is going to come from potentially for the mining study or the mining that you're going to be doing. And then obviously critical also is the community and land ownership details. The desktop assessment also allow you to look at the infrastructure, those roads, railway lines, pipelines, power supplies, and settlements. And in the proposed development, you might have to move some of these infrastructure. And as a result, it's better to get this information in place before you actually start, to know that you might have to remove some of these railway lines or power lines. Or if you're not able to remove the railway lines and power lines from your exploration area or your potential mining area, specifically if it's open cast mining, you then might have to neglect some of or cut out some of the exploration areas that you're looking at. Just a legislative review. You obviously have to identify legislative requirements specifically to that country or that jurisdiction. You need to understand and detail the authorization process. Typically, an EIA from start of application to the final submission will take at least a year, in some cases 2 years, depending on the community liaison that you have to do, and also what they refer to as RAPs, which is the Relocation Action Plan for Community Relocations. You then have to identify and engage the competent authorities that cover that area. You then also, I think, you have to get an indication who the landowners are, and also get agreements from those landowners. So in terms of South Africa, particularly, you might have landowner consent from community landowners. You then have to look at option agreements and potentially compensation agreements going forward. Here, it is critical that you identify these option agreements and compensation agreements that you might have to put into place, because you are going to have to sign some documentation with the community. And it's better to sign this documentation with the community and the authorities prior to you going into any full-scale exploration. So you've got an idea what the baseline requirements are going to be going forward. Also, the desktop, in terms of social assessments, you can use Google imagery, satellite imagery, you can use cadastral mapping, you can get your land ownership sorted out, you can get your population dynamics, community sizes that you might look at, also the services that actually associated with the area that you're looking at. The ecology, land use, and soil desktop studies, you can look at soil and satellite imagery here. There's a lot of published information regarding ecology, land use, and soils. You can identify your ecological units, you can delineate sensitive habitats, you can look at the current land use that you have, and then also look at the land capability and agricultural potential. The water, in terms, you can start looking at baseline water quality monitoring. This is pre-mining. Identify all other water, identify potential water impacts that you're having on your mining areas, identify seasonal variations, volumes and quality in the local systems, and identify local users and uses of the water. So if it's used for domestic, agriculture, or irrigation. In terms of baseline sampling, this is obviously when you're on site, you have all the legal agreements in place, the exploration is taking place, and the drilling would be going. You're then able to start some baseline information, and during the exploration phase, ideal opportunity for you to collect the baseline information. So here, this is the ecological sampling. You can look at seasonal variation, seasonal wetlands, fauna and flora, and any temporary wetlands. In terms of community mapping, also ideal opportunity here. This is a project in Mozambique. This is a community that's sitting on the ore body. So as a result, exploration drilling had to be done in between the houses and also in between the fields that the community is actually looking at, the community has for their livelihoods. As a result, here, your early agreement with the communities, how you're going to draw, where you're going to draw, where you're going to get the water from for the drilling, what compensation are you going to be giving to the community, and what's the best season of the year to actually do your drilling, because obviously you don't want to interfere with the growing of the crops, because that is usually over a 100 to 150 day period, and it's better then to keep your exploration out of the community agricultural lands in order to make a peaceful exploration program. So in terms of community mapping, you're looking at mapping of dwellings in the area. You collect community baseline data, population, livelihoods, culture, household dynamics, and you contextualize the requirements then for resettlement or compensation agreements. This resettlement and compensation agreements for potential movement of people from land for mining development is a major cost implication. It runs into tens of millions of dollars these days. The other thing in groundwater, you're able to collect water quality, and there's ambient water quality. You're able to identify groundwater users, groundwater dependent ecosystems. You're able to then to identify potential aquifers, specifically relevant in the copper cobalt areas where these aquifers are fairly good, and also you can use the dewatering of the aquifers for the water supply to the mine. You then determine groundwater levels. Obviously, it's going to impact on your mining design. You're able to look at potential resources, and then you look at if you're going to need any treatment requirements in terms of meeting baseline environmental quality, and you can defend post-construction operation and also versus the pre-mining conditions. So you have a database where you're able to then defend any potential claims against groundwater contamination. Surface water, you can look at baseline water quality, surface water users, catchment resource evaluation, and then pre-mining water quality and quantity. You can look at flow, volumes, flood lines. Here you're able to look at the flood lines, or even determine the flood lines during this period. As a result, keep all exploration out of the flood lines, and also potential mine development out of the flood lines. Ecology, this is the ecological status. This is what the environment is prior to mining, and the sensitivity of the environment prior to mining. Stakeholder engagement, this is critical also. I mean, obviously during the exploration phase, you're able then to identify who the stakeholders are, and able to map community plots and houses. You're able to put this into our GIS database, which you can use later to overlay with your exploration data to determine what potential communities you might have to move. Typically, you might have to move communities in a larger context than your mining area because of dust and other impacts that are associated with that. In South Africa, the context is that no community should be within 500 meters of a mine or a blasting area. So it's a critical issue that you identify these communities, and this all feeds into your relocation action plan and the costs of your relocation action plan. Stakeholder agreements, obviously the agreement for exploration activities. You stake the value of the land during this phase. You detail your compensation agreements, and this is prior to you starting. So you've got a baseline indication of what the compensation agreements are going to be, and obviously your prospecting licenses from there. And I'm sure you're all aware it's a major issue at the moment. It's what's referred to as the social license to operate. So this is the community agreement with the community. Look at the potential. If you're going to supply a mine with water, you have to then look at the potential water supply to communities that might be affected along the way. it's unlikely you're going to be able to put a pipeline through communities without a water pipeline through communities without actually supplying water to the communities, and that goes for roads and also power infrastructure. You look at community health situations where the clinics are, you look at the provision of corporate social investment, and that is a strategy that you identify during the exploration phase that you continue into the mining phase. The critical thing is also to have this data not only on a database, but to visually represent this data. So then you're able to look at your potential mining area regarding and in context with the infrastructure that's in place, the communities that are in place, the ecology in place in terms of minimizing the potential impact that you might have on the area. This little map shows the flood lines, it shows the potential open cast area, depends on the community, other areas. There's also some power lines across this area in terms of looking at how you would actually begin to actually understand what the impact on the baseline is going to be. So just some discussion points of what I want to talk about is the early benefits of environmental and social baseline studies. It provides early input into the feasibility studies. You then can look at international standards or the applicable standards, and it actually then starts prompting you in terms of the information that you require to collect during the environmental and social baseline study. So if ecology is a major issue, you're able then to concentrate more of your efforts on the ecology than anything else. It then gives you a budget and schedule information, it indicates the authorization process and the time it's going to be followed, it provides opportunity to realign, redesign location technology to the layout to avoid impacts and projected risks, and then maximizes the potential saving and expenditure during the exploration phase. So you can structure an intelligent project development process going forward. And how do we make this happen? I think one of the things is, and one of the areas close to my heart is obviously collection of information during exploration drilling. Groundwater information. Typically, you get to a mine site where there might have been 200-300 boreholes that have been drilled for resource evaluation, and none of those boreholes are equipped to actually monitor any groundwater data from those boreholes. So ideally, you can put in piezometers in cored holes where you actually can feed a piezometer. It must be anything bigger than 20 millimeters. Down the middle of a core barrel, if you're pulling out the core barrel, you're able then to leave the piezometer in there while and it'll stand open. If you're removing the core barrel and the borehole collapses, that allows us to measure water levels, it allows us to measure water quality, and as a result, we don't have to go into then the expense of drilling additional boreholes to get more information for the hydrological information. We do have a presentation, the collection of hydrological information during exploration, which is specifically aimed at how you collect this information. That's typically cores, fractures, voids, water losses during drilling, changes in water quality or temperature as you go down. Wireline geophysical data is obviously critical for us in terms of the hydrological information as well, where you can look at densities, you can look at fractures, you can look at fracture orientation. So that is actually very good for us to actually have a look at as well. So again, the Google imagery is to plot the potential geology and ore body. You then plot all the other layers on top of that. You can plot water levels, ecology, baseline agriculture, communities, and you're then able to look at what, if you're developing you're going to develop this ore body, what impact it's going to have on the area surrounding the proposed development that you're going to do. Community liaison, critical. I think during the exploration phase, obviously the exploration geologist has direct contact with these communities. This is critical that in these community programs that you then identify the community leaders, you continuously keep them informed of what's actually happening and the progression going forward. And you're able then to form a list of the community around there, of the skills the community has, in terms of utilization of the community going forward. You're able to engage in the community in a meaningful process, and you're able then to set up parameters and manage expectations going forward. Application also, you need to look at the linear infrastructure you're going to put into place, the impact that's going to have. You then look at the agricultural development that you might be influencing. You then have to look at commercial and industrial projects that might actually benefit your proposed mining development, and then obviously the rezoning applications that you have to put in going forward. In conclusion, early baseline studies allow you to identify and manage project risks, allows you to optimize expenditure in the exploration phase, informs design, layout, and alternatives and location of your potential mining areas. It manages stakeholder relationships and expectations. It allows you to streamline the authorization and permitting process by getting sufficient information before you start. It provides a comparative monitoring data. It optimizes the project schedule and budget, and obviously encourages the investment confidence going forward. I'd like to thank you all very much, and I'm very open to any questions.
We'll open the floor now to questions and comments. Thank you, Andrew, very much for this presentation. Maybe I'd start with one question. How do you feel as to the degree to which the environmental and social compact issues have been written into the various mineral codes around the world, the mineral reporting codes? Is there sufficient in them, or do those need to be revised?
I mean, at the moment, I think people are using the IFC and the World Bank requirements as the sort of the manual for anything going forward. So, and this obviously depends on where the funding for the proposed project goes to. But most work is done to IFC and World Bank standards. This usually supersedes the requirements of the nation that you're actually doing, or the local legislation. So you might have different agreements or different factors that you have to take into consideration depending on the local legislation compared to the World Bank legislation. And there might be some conflicts in these situations. So it's quite a minefield to go through. But to answer your question, I think the legislation is there and it's been pretty well written up.
Tony, you have your hand up.
Yep, Andrew, great talk there. Thanks. There's one issue that I think probably needs to be highlighted, that is really very close to the heart of what a geologist does, and that is the initial work in geochemistry for acid rock drainage studies. What I've found in my work is that when we eventually get to interrogate an exploration database, a lot of times some of the data that could have been picked up during the exploration phase from the drilling program, from the core samples and stuff, hasn't been collected and analyzed. It is also one of the it's a key input into the feasibility study, and it's part of the early studies that should be done on a project. Yeah, that's my comment.
Tony, I agree with you there. I mean, some of those acid-base accounting tests take 20 to 30 weeks to complete. So critical that you need representative core to put into those studies, and you need some of the ore deposit that you're going to be mining, because you need some, if they're going to take half the core or a quarter of the core, you definitely need some of that core to actually do your studies on, plus the roof and the floor. I agree with you, and I think it's a lot of that work is done from an analytical point of view to see what the elements or the concentration elements that you're looking at. But you can run geochemical studies or environmental geochemical studies in parallel with your essays.
Any other questions or comments? Maybe just one more from me. In terms of, well, here's someone's got their hand up. Nolene.
Hi, I just want to remind everybody that there'll be more information on the eSimon data collection software on Friday at 1 o'clock.
Okay, thank you very much.
Craig, just one question from me. I mean, would exploration geologists be interested in a course that we could speak to some of the academic institutions to run in terms of collection of baseline environmental information during exploration phase?
I think in principle the answer is yes to that. How one goes about it, I'm not quite sure. You don't need to necessarily do it through an academic institution. You could do it through a professional society, for example. But I think in general the answer is yes. Maybe one question for me is and something I've sort of suggested to a couple of department heads in the past. For anybody going through a geology curriculum at one of our universities, should those students be required to take 1 or 2 sociology courses as well in terms of dealing with the community? We always hear about how exploration geologists are the ambassadors on the ground of your country, but most of them are pretty poorly prepared for it. Any comment on that?
Hi, it's Megan here. Thank you, Andrew. Craig, just to comment on your question, I would definitely agree on your statement, because having been on the ground and having dealt with quite violent communities, that you are definitely not equipped as a geologist from ground level up to deal with these sort of situations.
Is there anybody from the academic community on the conference? Would you like to comment? We've got one here. Tanya Marshall.
It sounds like something that would fit very nicely into one of our GeoSkills courses.
Yeah.
Totally agree, Tanya. I've already got Andrew's name down.
And also the sociology section that Craig was talking about as well.
Yep, will do.
Tony again. Tony, I'm trying to unmute you.
From my perspective, I think that the social perspective, as well as the environmental perspective on projects, is hugely important. It's not only, I mean, it can make or break a project. Is what happens in the exploration phase, and the kind of interaction that you have, and the ability of an exploration geologist to understand the context and have the necessary understanding so that they can seek the help from the experts that are required at that stage.
I think we've got Tanya's hand up. Okay, there you go.
Okay, I just also wanted to remind everybody that come September, the GSSA is going to be putting on an environmental ESG full-day workshop. And I think that is also a forum that we can discuss many of these things. Hopefully there'll be a number of geologists exploration geologists, mine geologists attending that course. And I think some of these things could very well be put at that forum as well.
Tanya.
Hi, Tanya. I mean, that sounds great. As I've said before, I just hope that that course is also going to be in the virtual world, or available in the virtual world as well. Unfortunately, I'm sitting here in Peru in South America, and I would very much like to be on that on that course and many others that GSSA is putting on. So I hope that a lot of them are going to move into the virtual world, or at least have that option for some people that are further away than others.
Only yes, for very definite, the environmental course, I can speak for that one. We will be doing it online. If we can do it face-to-face, we'll do that as well. But there will very definitely be a virtual component to it.
Thanks, that sounds great.
Nolene, I think you wanted to say something?
I do. I just want to add to what Tanya's been saying. I think we all realize that the way we've been doing things up to now will have to change. And we definitely are bringing in a lot of virtual or online components to our offerings going forward. So Tanya, I hope to see lots more of you.
Thanks.
Are there any other comments, queries, or suggestions? If not, I'd like to thank Andrew very much for doing the presentation, and Nolene for organizing it. Thank you very much. I'll close the meeting now. We've got Murray Hitzman at 3 o'clock this afternoon, for those of you who want to tune in. Thank you very much. Have a good day, everybody.
Thank you. Bye-bye.
Ciao.
Thank you.
Thank you.
Thanks.
Thank you.